Myself Jyoti, and today I'm starting with a new topic, that is wave nature of particles, and this is lecture 1. So, according to Planck's postulate, radiation behaves as particles, and this was put forward by Planck, and Bohr used this Planck's postulate and succeeded in explaining the stable structure of atoms and discrete atomic spectra. Einstein, he also used the same thing to explain photoelectric effect. So, on the other hand, here what we are talking about is radiation behaving as particles, wave behaving as particles. On the other hand, there are certain experiments that showed that moving particles exhibit some typical wave properties like diffraction, interference. This led to wave nature of particles. So, last topic which I took was particle nature of waves, where radiation behaves as particles, and we successfully explained the Compton effect, where we considered radiation behaving as a particle nature of waves. Now we are focusing on wave nature of particles, that particles, they behave as a wave, and there are certain wave properties which are exhibited by particles. Okay, so what are matter waves? So waves which are associated with particles, they are called as matter waves, and this concept of matter waves was introduced by de Broglie, and he postulated that a dual character, that is wave character and particle character, should not be confined only to radiation. Till now we were talking about light behaving as a particle and wave, but according to de Broglie we cannot confine this dual nature only to radiation but also to particles. He related these two aspects of particles by the same equation as did Planck for radiation. So, according to Planck's hypothesis, we know that energy E of a photon of frequency nu, it is given by E equals to h nu. We very well know this equation. Now, from theory of relativity, we also know that E equals to mc square. So, if we combine these two equations, we have mc equals to, or we can write mc square equals to h nu, where h nu or mc, it is equals to h nu by c, just dividing both sides by c, and that is equals to h by lambda, because h nu by c, it is nothing but 1 by lambda. So I can write h nu by c equals to h by lambda, or p, it is equals to h by lambda, where p is the momentum, lambda is the wavelength of photon. So we are getting this equation, p equals to h by lambda, and lambda is the wavelength of photon. So de Broglie used the same equation to give his hypothesis, lambda equals to h upon p. So what is de Broglie hypothesis then? So in 1924, de Broglie postulated that particles in motion exhibit wave-like behavior, and the waves associated with particles are called as matter waves, or they are called as de Broglie waves. And the wavelength of de Broglie wave associated with a particle with momentum p is given by this equation, lambda equals to h by p, which is very important equation, and this equation is called as the de Broglie hypothesis. And see, if you can see this equation, this is lambda, it is the wave property, and here we have momentum p, that is the particle property. So this is the equation which is connecting wave nature with the particle nature. Now, if m is the mass of particle and v is its velocity, then we know that momentum of the particle p, it is given by m into v. So we can write this as lambda equals to h upon mv. So here in for m, for p, I have substituted mv. So this is the second form of de Broglie hypothesis. So either you can write lambda equals to h by p, or lambda equals to h upon mv, and you should know all these forms so as to solve numericals, because if in the problem p is given, then we use lambda equals to h by p. If in the numerical velocity is given, then we will be using the second form, that is lambda equals to h upon mv, and there are other forms too. Now for free particles, energy of a particle E is given by E equals to P square by 2m. We very well know this. So, so if I write E equals to P square by twice m, I can write P square equals to 2me, or I can write P equals to under root of 2me. So here the same equation for p I can write under root 2 me, and I will get this third form, lambda equals to h upon under root 2 me. So if in the problem energy is given, then I have to use this form. This is the third form, lambda equals to h upon under root 2 me. And we know that when a charged particle it is accelerated through a potential difference v, then it gains energy, and that energy gained by particle it is given by E equals to q into v. So just now we got the third from lambda equals to h upon under root of 2 me. For that E, we can substitute E equals to qv, and then we will get this fourth form, lambda equals to h upon under root 2 mev. Now here, when we are writing third equation and fourth equation, third equation is lambda equals to h upon root 2 me, and fourth equation is lambda equals to h upon root 2 mqv. Now when we are writing this third and fourth equation, it is important to know that the mass m in equations 3 and equation 4 is the mass of moving particle and not its rest mass. If m0 is the rest mass of the particle moving with velocity v, then the mass of the moving particle m is given by m equals to m0 root of 1 minus v square by c square. So here we are assuming that the particle which is a moving particle, it has velocity comparable with the velocity of light. That is how we are using this relativistic equation. So whenever a particle it has velocity comparable with the velocity of light, it is moving, then its mass is given by this formula, m equals to m0 root of 1 minus v square by c square. This equation gives the relativistic mass of the particle. For low energy particles, v is much smaller than c, m is practically equals to m0. Okay, but if we have a very highly energetic particles, in that case velocity of those particles it is comparable with the velocity of light, and then m is not equals to m0. You have to use this formula for m, that is m equals to m equals to m0 root of 1 minus v square by c square. So thank you so much. So we have learned four forms. These four forms you have to remember so that we can solve numericals. So first is lambda equals to h by p. Second is lambda equals to h upon mv. Third is lambda equals to h upon root 2 me. Fourth is lambda equals to h upon root 2 m qv. Okay, thank you.